Hi everybody, happy Martin Luther King Day. So today I'm going to kind of finish up what we didn't finish last Saturday on our lesson. I told you I'd send you a video on what's remaining on the notes. Normally we won't do that, and we'll usually finish in class, but it is a hybrid, so part of that is online material at times, but we won't always need this, but we may do some of this in the future. So I wanted to start off, I know we did these two, but I think they're important enough. I want to just kind of reiterate some of these on the worksheet. So we talked about in class certain of the properties of limits, and we talked about rational functions, which are kind of like fractional functions. This is a fraction here, so this would be a rational. And one thing you could try is to just substitute your limit into a rational function. So if we do this, we'd end up with 4 squared minus 6x, which would be 4 plus 8, over 4 squared minus 9 times 4 plus 20. What turns out the top would be 16 plus 8, which is 24, minus 6 times 4, which is 24. That turns out to be 0. Over the bottom would be 4 squared plus 20, that's 16 plus 20 is 36. 9 times 4 is 36. 36 minus 36 turns out to be 0. This is what we call an indeterminate form. Indeterminate form. Now, it doesn't mean there's no limit here, not quite yet. So what you would do is attempt other things first before we determine the limit does not exist. So the other things would be in the form of factoring. So we talked about this in class. I would get the factors of 8. So I'm gonna list those here. Factors of 8, 1 and 8, 2 and 4. Of those factors, which ones can add or subtract to 6? That would be 2 and 4. So I'm gonna rewrite this as, you always gotta write the limit, as x approaches 4 of, we're gonna do 2 parentheses, x, and I want these factors to multiply to positive 8 and add up to negative 6. The only way that's going to happen is negative 2, negative 4. Do a quick check. Negative 2 to negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. So this works. The top is factored. I'm going to make a list for factors of 20, 1 and 20, 2 and 10, and 4 and 5. Of those factors, which ones can I get to add or subtract to negative 9? The only way I'm going to get that is with 4 and 5. Now, I'll do a similar thing here, and I need to make them multiply to 20 and add up to negative 9. The only way that's going to happen is negative 4, negative 5, right? So the rule is you gotta, if this is x squared, the first term is x squared, then your c term, right, because it's ax squared plus bx plus c, your c term has to be, or your two numbers have to multiply to your c term and add up to your b term. So here we'll notice these two cancel out, usually indicating that there's some kind of hole in this graph. And then so we would graph what's remaining, or not necessarily graph, but we use what's remaining and evaluate the limit there and see if there's any problems. So if I evaluate the limit here, 4 minus 2 over 4 minus 5. Okay, and I'm going to go ahead and erase this intermediate form for space. So 2 over negative 1, which is negative 2. So that is the limit at that point. So again, the first thing you should try is direct substitution, like we talked about in class. If that doesn't work, and it didn't work because it ended up giving us that 0 over 0 form, it's indeterminate. We try other things. The other things we could try is see if it can factor, and if it factors out and there's cancellation, see if you can plug into what's left over. Okay. So with that said, let's move on to example 2 here, and I'll go ahead and change colors just so you can tell which one's number 1 and which is number 2. So here we have a difference of squares. And I think I mentioned this in class right? A squared minus b squared equals, can be factored out to a minus b times a plus b. Okay, you could always work it out and you'll see that it comes out to a squared minus b squared. So what this factors to is x minus 1 times x plus 1. On the bottom, it's kind of similar to what we have up here, so I want factors of 1. I don't even think I'm going to write that, right? Because factors of 1 are obviously just 1 and 1. And I would want to write an x here, an x here. And the only way that's going to multiply to 1, add up to negative 2, is if they're both negative 1s. Okay. Now from here, I see that there'd be cancellation. And also to note, I didn't do it, but if I plug it in, if I tried direct substitution, which is what we should do first, 1 squared minus 1 would be 0. 1 squared is 1, minus 2 times 1 is minus 2, that's negative 1. Negative 1 plus 1 is 0. It's actually an indeterminate form again. That's why we tried the factoring. Okay, I don't want to miss that point. So now, if we plug this in, we end up with, if we try to plug it in, we end up with this 1 over 0. Okay, so 1 over 0, can I do 1 over 0, or can I divide 1 over 0? The answer is no. Okay, so and I'm just going to kind of jump to it. From that, I can kind of tell this does not exist. The limit does not exist. But let's go a little bit deeper, though. If I graph this, and you have graphing calculators, or at least I gave you access to some, you can also go to Desmos.com. You can type this in, just this part, and it'll show you a picture of this on your computer if you want a quick picture. But we're going to do it just from here, though. If I were to sketch this graph, I'm going to talk about something which you may have heard, but maybe been a while. If whatever makes this denominator 0, that's what we call vertical asymptote. So x equals 1. So there's an x equals 1 here. Also, and we're going to go over this again and again, so this is just kind of doing it by hand, but also this has a power of 1, that has a power of 1, the coefficient is 1, and the coefficient here is 1. So if I divide the coefficients of something that has the same power, I end up with my horizontal asymptote. So in other words, 1 divided by 1 is 1, so my horizontal asymptote is going to go through 1. Okay, so what does this do? This is going to guide my graph. I still want some points before 1, so I want to plug in maybe like 0 into here. Here, I'll make a kind of limited on space here, but I'm going to make a table. I'm going to plug in 0, and then I'm going to plug in a point after the vertical asymptote, so I'm going to plug in 2. Okay, so here we go. 0 plus 1 is 1. 0 minus 1 is negative 1. 1 divided by negative 1 is negative 1. That's my coordinate. 0, negative 1. I have a point right here. Now I'm going to go to the other side, 2. 2 plus 1 is 3. 2 minus 1 is 1. 3 divided by 1 is 3. So now I have another point, 2 comma 3. This will be right here. Now, just kind of knowing, I can plot more points, but just kind of understanding how these, what we call rational functions, work. There's going to be more points, and it's going to come this way, but it's guided by this horizontal asymptote, and when I get closer to the vertical, it's going to be guided by the vertical. This is going to do kind of a similar thing, guided by the vertical here, and guided by the horizontal here. So, the reason I drew this picture is because I want you to see why this does not exist. The limit as x approaches 1 right here goes to what? It goes to negative infinity. And the limit as this one approaches 1 from the right goes to positive infinity. Okay? So that does not exist. Which that's kind of the first time I mentioned going to infinity, and negative infinity and positive infinity. So as I approach from the left hand side, we go, my f of x goes to negative infinity. As I approach 1 from the right side, my graph goes to positive infinity. So in other words, they don't approach the same thing, so the limit does not exist. Okay, so that one was kind of a longer example. Let's kind of get through some of these other ones. So on this one, you have a number in front of your x squared. So this, when you have a number in front of the x squared, unlike these two, you're not only going to get the factors of the c, you're going to get factors of a times c. Okay, so this is a little bit different. So a times c would be, this is a, that's b, that's c. So a times c, 2 times 3, is going to give us 6. It actually gives us -6, but we're gonna start with the positive, and then we'll work the negative in there. 1, 6, 2, 3 is the only factors. So now, kind of in the same way, you want to, and this one's going to be kind of a tricky one because it seems like 2 of them work. But remember, you want them to, it still needs to multiply to -6, in fact. Okay, so we got to keep that in mind. It needs to multiply to -6. I just kind of keep it positive just to make it easy. So I need to break this up to 2x squared. And how am I going to get this to give me -6? Multiply to -6, it would have to be this one. And 1 would have to be negative, because -1 plus 6 would give me positive 5x. -1 times 6 would give me -6. This would be the one it has to be. Okay. Like I said, this one's kind of a tricky one. Usually it's a lot more obvious. So what we're going to do with this 1 and the 6 is we're going to break this up. We're going to break the 5x up to -1x plus 6x. Think about that for a second. Is this the same thing as this? Yes. -x plus 6x give me 5x. So it's exactly the same. Okay. So and we're going to do something else with that, and I'm going to erase what I have here. So now I'm going to factor the bottom. Factors of 3 is x squared plus, I can just go ahead and factor it. Factors of 3, I'm not even going to list them because factors of 3 are only 1 and 3, and that has to be +1 plus 3. Okay. With the top, you always got to write the limit. And you should always write equals in between your steps. Okay, so you should model good math writing. In other words, you should kind of follow along with what I'm doing, and that's how you should write your mathematics. Everything. Okay, all the symbols. Pay attention to careful detail. That's what'll go into your test. Okay, the only way you're going to pay attention to careful detail is do it as you're doing your homework. Now, I'm going to still write the limit. And I got one more step here on this. Now, this is called factoring by grouping. So you're going to group these two as first group and a second group. Okay, just like this. Now, what's the common factor in the first group? I see an x here and an x here, so I'm going to factor that out. And I'm going to be left with, divide this by x, you get 2x. Divide this by x, you're going to get -1. Okay. Now, what's the common factor over here? I see a 3 in both of them, so I'm going to factor out a 3. Okay. Divide that by 3, you get x. Divide that by 3, you get 1. Okay. And let's see here. Give me 1 second. I gotta look at this. Okay, I caught my error here. Here, 3 goes into both of these, so you divide this by 3, you actually end up getting 2x minus 1. Okay, which would be a lot better. And you'll notice something. Okay, you'll notice that they both have 2x. On the bottom, let me just go ahead and rewrite what I have. Okay, so then you'll notice you have 2x minus 1, 2x minus 1, so what you could do is factor that out. You factor those two out, and you write what's left over. What's left over? X plus 3. That's the other factor. Okay. I'm going to go back and write the limit on here because I didn't do that, but you need to. Okay, on every step. Otherwise, the previous step doesn't equal. This step doesn't equal that step as x approaches 4. Now you'll notice something here. X plus 3 cancels out with X plus 3. After we factor it, now we can just plug in 4. And again, why couldn't we just plug in 4? And this might have been an exercise more. Yeah, we could have plugged in 4. We got the same answer. So I think what I'm trying to do here on these problems is show you how to factor. Okay, but at the same time show you how to find a limit. So we'll do it. We could have finished this problem essentially in 30 seconds. Plug in 4, right? Because actually, if you plugged in 4, there is no problem. But this should give us the same thing too. 2 times 4 is 8. 8 minus 1 is 7. Over 4 plus 1 is 5. So 7 over 5. Okay, so we had a little exploration here. Showed you how to factor, which is going to be an important skill. But let me not gloss over this fact. If I plugged in 4 here, it'll give us exactly the same thing right from the start, which is the first thing you should try. Okay, but sometimes I'm showing you things not for just to find what we're looking for, but to brush up on some of these other skills, which I'm going to do over here too. Because this one, actually no, this one you'll find if you plug in 1 squared plus 2 times 1, that's 3. 3 minus 3 is 0. You're dividing by 0. So that is, you won't be able to do that. So we must attempt something else in the form of trying to factor. So we're going to do that. I'll start with 3 times 6. That's 8 times c because there's a number here. So it's 18. So I need factors of 18. I always start with 1, 1 and 18, 2 and 9, and 3 and 6, and there's no other factors of 18. So of those, I need factors that'll in some way get me 7. Like I said, it's usually a little bit more obvious than the first one. That's the only way you're going to get 7. So we're going to break the 7 up. So I'm going to write limit as x approaches 1 of 3x squared. And now I'm going to write plus 9x minus 2x. That gives me 7x minus 6. Okay, over, I'm going to go ahead and factor the bottom. It's only 3, so it's x minus 1 it has to be, and x plus 3, because 1 times negative 1 times 3 gives you negative 3, negative 1 plus 3 gives you positive 2. And now we're going to work on factoring the top. So again, we're going to factor by grouping. So we're going to group this piece and this piece. So I'm going to write common factor of the first group would be 3x. I'm going to put the 3x on the outside, divide that by 3x, you get x. Divide the second by 3x, so it's 9x divided by 3x is 3. Common factor of the second group would be negative 2, because I see a negative 2 in here, negative 2 in here. Divide negative 2x by negative 2, you get x. Divide negative 6 by negative 2, you get 3. Okay, which we'll start to see x minus 1 times x plus 3. Then we got to squeeze. I got to give myself reminders too. Make sure you put the limit in every step, and then we can write this a little bit easier, or continue to factor. You'll notice that there's an x plus 3 here, x plus 3 here, so you can factor that out. And you write what's remaining, which is 3x minus 2. Okay, 3x minus 2. Okay, squeeze that in there, and then you get x minus 1, x plus 3. And you'll notice the x plus 3's cancel. And now we try to plug it in, and what we'll notice is we still can't get a limit because we'll end up with the same thing, and there's nothing else I can do as far as plugging numbers in. So I end up with negative 2 over 0, which is a dead end in that sense, but in other words, we'll determine that there's this would be undefined. And it'll be a similar graph. Now, to further confirm this, I've given you several methods. In class, I showed you you can approach a limit, like you can make a table 0.9, 0.99, 0.999. That's the limit as it approaches the left, and the right would be 1.001, 1.01, 1.1. So you approach it from the right. You can plug in numbers like that, and you should see what the limit is, or if there's a limit. If there's no limit, they'll go to different numbers. If there is a limit, they'll go to the same numbers on the left and the right. You could also verify with the graph. So you could type this in to your calculator. I also told you about Desmos. Mentioned Desmos software. You can try that to verify. Now again, you need to know how to do all of it by hand, but to learn it, to grasp it, graphs are helpful and tables are helpful to see a picture of it. So this one's going to end up being does not exist. Okay, and that could be true. Okay, so these last two are a little faster. Kind of same approach. Try to plug it in. Not going to happen, right? Because you plug in 0 here, you won't get it. So next best thing, try to factor. Okay, so x minus 5, because x is in here and in here. Divide x squared by x, you get x. Divide 5x by x, you get 5. Over x. Well, hey, guess what? X's cancel. Now I can plug in 0 into my limit. My answer is -5. Okay, which you could also verify with the graph. Okay, which I would encourage you to go look at all the graphs on these. Desmos is great for that. Also, your graphing, your TI-84 calculator is great for that. Okay, same issue. You have 0, it's not going to happen. You plug it in, you're going to be dividing by 0. You cannot do that. So the limit as x approaches 0, I see a common factor. We'll try to factor. So it's going to be 3x, and 3x squared divided by 3x will give us x. Negative 9x divided by 3x give us -3. Over x, you'll notice the x's cancel, and now we can plug in 0. 0 minus 3 is -3. 3 times -3 is -9. Okay, so that would be your answer there. Okay, so good start so far, and we'll go do the last couple of questions. Okay, so these are called difference quotients, and basically what we're going to do is we're going to plug in. We have an f of x, and they want us to find the limit as h approaches 0 of f of a plus h minus f of a over h, which seems like a lot, but you need to take it in steps. So step 1, we're going to do f of a plus h. What does that mean? F of a plus h. F of a plus h means you're going to substitute a plus h in for x. That's all it really means. So we're going to do 2, instead of x, I'm going to write a plus h. A plus h. That's all it means. When I substitute, if I distribute 2 times a, 2 times h, it's 2a plus 2h minus 3. Step 1's done. Step 2, this process, we're going to do f of a plus h minus f of a. Okay, so we already have f of a plus h, that's this. So I'm not going to do extra work, I'm just going to write it in. Minus f of a. Well, what's f of a? F of a means substitute a in for x. But the thing you got to be careful on, you got to do minus, but all of what you sub in. So meaning 2 times a minus 3. Notice the parentheses around, this is around f of a right here. Then we can distribute the negatives, so we'd end up with 2a plus 2h minus 3 minus 2a, negative times a negative, because you got to distribute the negative to the 2a and to the -3, so that'll be positive 3. What do you notice? The 2a's cancel out, the 3's cancel out, you're left with 2h. Okay, so step 2 is done. We did f of a plus h minus f of a. Step 3, we're going to do f of a plus h minus f of a, now divided by h. Well, we already have all this. That's step 2. That's 2h. Divided by h is, the h is cancelled, so you get 2. So step 3 is done. Step 4 is find the limit as h approaches 0 of 2. Well, by one of our properties, it's a constant, so the limit as h approaches 0 of 2 is just going to be 2. So that's how you take the steps. Now, this one will be kind of the same, pretty much the same, but now instead of a, you have a number, 5. Okay? So you can see them either way, but we're going to take the same steps. Okay, so I'm going to do, I'm going to change up the color first of all. I'm going to do step 1, and we're going to do f of 5 plus h. F of 5 plus h, just that part. So what does that mean? Substitute 5 plus h for anywhere you see x. So 5 times 5 plus h plus 4. And then simplify where you can. I'm going to have to distribute this 5. 5 times 5 is 25. 5 times h is 5h plus 4. Put this together. 25 plus 4 is 29, or combine like terms. That's 5h. So that's step 1. Step 2 will be f of 5 plus h minus f of 5. F of 5 plus h minus f of 5. Okay. Well, f of 5 plus h we already have, right? That's the previous step. 29 plus 5h. So we're not going to redo that. Minus f of 5. Well, what does f of 5 mean? F of 5 means plug 5 in to your problem. Remember, you got to put it in parentheses. So 5 times 5 plus 4. Okay, so 5 times 5 is 25 plus 4 is 29. Okay, maybe, hopefully you're okay if I skip this step, but that's 29 and that's 29, and that's minus. So in other words, let's just cancel. Save myself some writing there. 5, that's 5h. So that's step 2. Step 3 would be f of 5 plus h minus f of 5 divided by h. Okay, so f of 5 plus h minus f of 5. Excuse my 5s. People always tell me my 5s are bad. But those are 5s. Over h. Well, I already know the top. From the previous step, it's 5h. So basically, it's just 5h over h, which is 5. Okay, again. Step 4, find the limit as h approaches 0 of 5. Well, from one of our properties we talked about in class, the limit as h approaches 0 of a constant is just the constant itself. Okay, and that answers those two. Okay, so I decided I'm just going to do this one, which is the harder one of the two, and then leave the other one as a practice, kind of like what I would do in class, actually. So let's get started here. It's going to be the same steps. You'll notice that it's not linear like in mx plus b, it's quadratic. We have an x squared term. So we're going to take the same steps, but although some of the steps in between might look a little bit different because of it being a quadratic, but it's just algebra. This means the same thing. You're going to replace all the x's with 3 plus h. So I got to do 2 times 3 plus h squared, because it's squared, minus 3 times 3 plus h plus 1. So basically 3 plus h just went in for the x's there. Now we're going to do 3 plus h times 3 plus h. So my goal is for you to be able to do this in your head, but I'm going to show it one time. This is what's going on, right? 3 plus h squared is actually 3 plus h times 3 plus h. 3 plus h times itself. 3 times 3, so you're going to do 3 times that, 3 times both of these. 3 times 3 is 9, 3 times h is 3h. So that's done. Then I'm going to do h times both of these. H times 3 is 3h, h times h is h squared. 3h plus 3h adds together, so you end up with 9 plus 6h plus h squared, which usually we don't write it in that order. We usually write it in the other order. H squared plus 6h plus 9. So that's a lot of writing, I think, and that's something you're going to have to do often. I would prefer you to be able to do this in your head. So I'm going to show you. I don't guarantee you'll master it right now, but work on this. I think you could if you take some time with it, and it'll be helpful for you in the future. So this is how I do it. H times h, or we can start with 3 times 8. We'll get to this. 3 times 3 is 9. 3 times h is 3h. H times 3 is 3h, which adds up to 6h. H times h is h squared. Okay? And then you could always reorganize that. So again, 3 times 3 is 9. 3 times h is 3h. H times 3 is 3h, which adds up to 6h, and h times h is h squared. But anyways, that can be very helpful, because instead of doing, how many lines is that? 1, 2, 3, 4. 4 lines of work, you got 1 line of work. So moving on. Here you can distribute. That's minus 9, negative 3 times 3, and negative 3 times h is negative 3h plus 1. Here, you'll distribute the 2, so it's 2h squared plus 12h plus 18. Negative 9 plus 1, that's negative 8. Negative 8 minus 3h. Okay. Combining any like terms we have left, so 2h squared, 12h minus 3h, that's 9h. 18 minus 8, that's 10. Okay, and that'll be my step 1. Okay, so that one was kind of longer than our original step 1. So let's move on to step 2. Which step 2 is find f of 3 plus h minus f of 3. Okay, well we already have that, right, from the first step. 2h squared plus 9h plus 10 minus f of 3. Well, what does that mean? Plug 3 into your function. So 3 squared is 9. 9 times 2 is 18. Right here, I can write it out. 2 times 3 squared minus 3 times 3 plus 1. Okay, so I plug 3 into here. Which, now I'll do it. That's going to be 9 times 2 is 18, minus 9 is 9, 9 plus 1, this is going to end up being 10. Well, if that's 10 and this is 10, here, let me save myself some writing, that's going to cancel out. Make sure you show the work and do all that. Here, I feel like here, let's do this. It's minus 10, there you go. Just so everybody sees. That's 10, so that's 10, 10 minus 10, that cancels out. There's my answer for step 2. 2h squared plus 9h. So step 3 would be f of 3 plus h minus f of 3 over h. We already have all this from the previous step. The only thing I would do, here, and I'll do it right here. Okay, so I'm just going to put that over h. On the top, you see that there's an h and an h. I could actually factor that out. So that's going to be 2h plus 9 over h, which that cancels out, which is 2h plus 9. Okay. So I'm almost done. Step 4 would be evaluate the limit as h approaches 0 of 2h plus 9. Okay, so this will end up being, plug in 0, you end up with 9. Okay, so that's how you calculate the difference quotient, which is actually what we'll call the definition of the derivative in future courses, which is a big part of this class. But for now, it's a difference quotient. I just want you to be able to understand the steps. One, you plug in the f plus 3 plus h, or f of 3 plus h. Step 2, f of 3 plus h minus f of 3. Step 3, f of 3 plus h minus f of 3 over h. And step 4, find the limit of all of that. And that's all we'll have time for today. I would hopefully you've seen this, and then you should be able to do the homework just fine. So make sure you do that by Friday. See you.